Now we'll talk a little bit more about the building management system. So building management systems is about knowing some of the systems that is actually available in the market. So BMS is also known as a building management system. The main goal of building management system is to optimize building performance and so they ensure efficient operations of various systems. BMS uses sensors as well as some actuator to monitor and control building equipment. Right, so the terms on BMS or building management systems, right, refers to the ability of the BMS to be adapted and response to a change in the building environment. Some of the key features of BMS is the creation of graphics, right, which allow users to visualize and manage the building systems. BMS is also known as building management system. So these are some of the thoughts that we actually could have. Right. So studying this, right, the building management systems, explaining the functions of building management systems, you describe some hardware configurations of building management systems, understand the operation and control loops, list the types of sensors, understand different control methods, and develop trends in the building management systems. So with that, right, we really talk about some of the automation, HVAC protocol, on-off protocol, DDCs, basically direct digital converter, measurements of verification, and analog signals, digital signals. So BMS systems is basically a centralized network of hardware that manage the facilities and built environment. It goes out of building automation systems, right? Sometimes these BMS and BAS are used often interchangeably. Then this is the American Society of Refrigerant and Air Conditioning Engineering, sometimes called ASHRAE, developed a BACnet protocol for data exchange, which is open and standard. So some of the major supplier BMS are like Schneider, Siemens, Johnson Control, and Honeywell. So this is some of the structure. And then there's some TV. This is the workstation. Some uninterrupted power supply. And then some of the IP cameras, internet protocol cameras where you can see different parts. And then chiller system. This is the DDC, which is the direct digital control, and some data logger as you can see. So there's a training at 1 minute interval. So M&V is often referred as measurements verification. So it's according to the environmental code, which actually we had sometimes in the plant, and it displays some key indicators as well as calculated heat balance. So in practical 2, you actually learn about calculating heat balance. Is basically your heat absorbed minus away whatever is going to be expelled. So this is kind of the heat exchange system. So it's this instrumentation, right, is a resultant of the systems within the 5%. So that is according to some standard practice of 5 SS 5591. So this is how it looks like, right? And then magnetic flow meter sometimes is 1% uncertainty capability of electronic institute verification up to 2%. So sometimes calibration is needed. But either way, the whole idea of heat balance, right, is to make sure that the sensors are provided condenser shall measure to have a systems retain good coverage up to about 0.05 degrees C. Is to actually have the measurement systems in range. So a heat balance sustaining the test of the chilled water to be computed with the Singapore standard SS591, so verification and instrumentation, and AHU monitoring control is something that we will see around here. So human temperature and humidity control is something that we will see in the system itself, and some of the temperature sensors, ventilation fans, lightings. So this is some high like commercial. Commercial is basically in the commercial building how it looks like, electrical system through the internet, and how the BMS actually works by itself with light control, temperature, HVAC, energy, access control, etc. So cloud systems to deliver in the internet protocol, processing large amount of data stored in the data analytics could be a TCP PIP, which is the Transmission Control Protocol, Internet Protocol, or DDC, Digital Control, and of course some of the uninterrupted power supply that some of the cloud services that we will actually get. So monitoring services and control BMS like HVAC, temperature control, lighting control, energy control, and access control are some of the controls that we actually use. Right. And then sensors, as mentioned, there's various sensors that parameter of such sensors in the air, common HVAC sensors and use of temperature sensors for relative humidity, all sensors like air measurements of velocity, pressure. It's a way to actually measure stuff. A lot of time we use sensors for safety parameters, and you actually has a high or low level water, or you actually has some fire or smoke alarm. Then we can mount ducting in the temperature sensor, which actually we have some air temperature sensor. So this is where we can mount some of the ducting, and then the temperature sensors will then sense either on coil or off coil temperature. Right? So the direct mounting temperature, yeah, these are some of the CO2, if you remember taking it is, and then some of the pressure sensor, right? And then parameters include some of the what you call the temperature, relative humidity, CO2, pressure, air velocity, and airflow, right? So sensor and transmitter actually has different type. So thermometer, which actually sense temperature, is called temperature sensors, and then it's readable out. So when the readable out portion, right, sometimes we call a digital sensors, is also called a transducer, which provides some of the electronics output, which converts the electronics power signal into either a mini volt so that you can actually read it. So several types of sensors could be from resisting thermocouple, right? Like we have seen some Lenco elements, copper, platinum, 10K sensors to thermistors, and then some sensor temperature for humidity, pressure can range from usually we use 0.5 volt or 0 to 10 volt, sometimes 4 to 20 milliamp. So control systems is something that is a little bit more challenging. Control systems, the process of AHU can involve in some steps. Sensor measure the parameter, and then the controller or the process controller set a point, and then the controller activates some action, and then the action could be like opening or closing of the valve. The process control is by adjusting the set point and providing site. So this is somehow like a control loop. There's a desired value. So for example, it could be 15 degrees is desirable. It goes through a controller. So the controller could be a valve putting in some signal. Then you have a valve motor, which is the actuator, how you actuate, and then room heating can be a process, and then back to the sensor again. So this could be a path that is actually been working on that. So BMS controller and control of AHU. So BMS control systems, sensor measures control variables such as temperature, humidity, flow rate to the controller, and then DDC, which is the direct digital controller, receive input from the sensors, process it, and then pump it up to the control device. Control device, example, the motor and chill water device act modified on the control variables, and then the controller is usually 10 volts circuit, and the controller send back the signal and then control the variables. So this is how control systems can I kind of easily do. So BMS terminal usually allow on-off equipment, change the setting from off, and then the control variables of status equipment. So data can also be accessed through this internet. So something about controller response is the time where the controller take the input from the sensors, right? Then you apply some logics to it. So when you think through, it's like applying logic to it, and then it calls output action. So this signal is kind of sent directly to the device, and then how the logical control can automatically through to the control device. So it means that, for example, you see a apple, so you are the controller. Your response is, "Hey, I want to eat that particular apple," and then you bite. You take the apple, and then you bite, right? So the thinking methodology is very similar to a controller response, except that the controller response, of course, is a process control. While just now what I mentioned, eating an apple, right, is a proper signal from your brain to basically pick up, have the action, and then have the execution. So logic of the control consists of the response to it. For example, just like I mentioned, right, you want to have the apple, the control is to take the apple and eat. In this case, the control logic says that, hey, I want to reach out for a certain temperature, and then there's certain logics to make sure that that temperature rise, either turn the fan off or heat up the air. So that is a certain logic. So the control mechanism is usually one that I would kind of like to share. So there's two positions, on off you can turn on or turn off, it's just like a fan. Proportional control is something like a damper position where you can immediate position, you control it, and then it's a sudden change. So it's proportionally, for example, maybe you have some chilled water, and then you will have some valve. So you want 1 degree of chilled water to open, it could be opening of valve at 1 mm. So that is kind of proportional control. So basically it helps to eliminate the frequency of tuning by having kind of straight line. Usually such is a proportional control. And then the other piece is called PI. PI is proportional integral. Integral, by the time if you have heard of this word integration, it integrates when you bring one more step faster. So integrate, it becomes faster, right? So you apply the similar logic instead of 1 degree of temperature rise by 1 mm. Maybe you say that, hey, I want to rise over 5 degrees, right? And then from 1 to 4 degrees, I can raise in maybe a very fast speed, and then it kind of attenuate down. So this type of control, a lot of time we call it a proportional integral control that handle the basically in terms of the chill water bath or some of the air handling unit. Right, so the other piece that we talk about will be PID, which is a proportional integral derivative control. So a lot of time we use this type of control to make sure that you turn on and off, but it's always there's a cyclic motion, sometimes it's overshoot or undershoot. But either way, the whole idea is some proportional to your control itself, and then you integrate, which means fasten it, then you differentiate. Differentiate is to find a shorter distance, right, or optimize area, so then you bring down the temperature or the control set point. So that's how it can be done as a proportional control. All right. So application and limitation, right? Okay, talk about some limitation. Of course, sometimes PID controls is not really kind of accurate. So sometimes there is really not so precise. So it's imprecise and relatively, but it's relatively inexpensive, but it's sometimes difficult to tune. So application used for simple cooling, acceptable range, control range, and sometimes systems is sufficient for fine tune frequency tuning on and off, right? So some of the control device like this is response for the signal from the controller, change the condition of the control medium. Often is an actuator and mechanical damper that builds with it, right? So that you can actually control the systems itself. So DDC is a direct digital control where you have a microprocessor. Microprocessor is nothing much but a processor which is small enough to put the logic inside, and then it allows the equipment to directly control without relying on the central management systems, right? So BMS trend. So what are the trend that is actually happening in basically the building management systems is as interoperable network protocols such as BACnet is commonly adopted, then the BMS is able to link up with some external module such as energy management system, IoT. Integrating of the enterprise to support such business is sometimes key. So things like booking of room, key assignment could also be a trend of the BMS, right? BMS is also able to export data, and then you have the monitoring facility to update continuous data over the cloud. So in long-term analysis can be done. So terminology, analog signal is a continuous varying signals over a period of time, and well, the temperature of the reading from a thermometer, right, could be 0 to 10 volt.
then convert that to an electrical signal. So a signal could also refer to a point or pattern and has some discrete in the values of a set point. Yeah, so this is basically some tutorial, and then the questions are available there, so you can kind of read through the questions. So that we will discuss the questions in kind of chapter 4 or lessons 4.